computer so that I'll be able to post them. So I'm sharing my screen now with the sound on, otherwise you won't hear anything. So with the sound on, so I'm sharing my screen with you. So, and now go to the products here, and then go to the system software. I think we did all of them, right? The hardware part we did. I think there's nothing more here, right? So unless you want to see the computer hardware careers. So, and we come back to here, OS, interfaces, operating systems, facts. Maybe you would like to see the, but you already have been completed. Graphical user interface, command line interface, disk management, file management, process management, application development. Suraya is waiting in the waiting room. Admitted. Let me see if anyone is in the waiting room. Yeah, Suraya joined with 2 devices. Okay, all right. So let's go to the topic that we were looking at. So computer software. So explore Windows, right? This is what I actually posted them. So before that, we will have a video, right? To some of you, not some of you, to most
In
of
this
you,
lab,
maybe
you'll
it's
perform a
trivial,
variety of
but
tasks
it's
in the
okay to
Windows
keep.
10 environment. First, we'll configure the screensaver settings. Open the Settings app by clicking Start, then the gear icon. Click Personalization. On the left pane, click Lock Screen. Scroll down, then click Screensaver Settings. Set the screensaver to Photos and set the wait time to 5 minutes. Check the box to display the logon screen when the computer exits the screensaver, then click OK. Click Home to go back to the main menu. Next, we'll enable Remote Desktop. This will let authorized users access this computer remotely from a different computer. Click System, then on the left, click Remote Desktop. Set the switch to On, then click Confirm. We're done with the Settings app, so we can close it by clicking this X. Now we want to create a new folder. Open File Explorer. Click this PC, then double-click the D drive. Right-click into the white space, then select New, Folder. Type the name Reports, then press Enter. Finally, we want to enable a network adapter. Right now, we can see that we don't have a network connection. Click the network icon, then click Network and Internet Settings. Click Change Adapter Options. Right-click the Ethernet adapter and select Enable. Now we have a network connection.
That is what it is your lab too, right? You know, one of the assignments. So you will be doing that very easily.
This is the one in the assignment?
Also, this is the one and the assignment. So it should be much very easy. Nothing, right? You can do it just like that.
The assignment one is to set tasks, no? If I remember.
Yeah,
It's
there
like
is
to
one
set-
task also. We'll show you that also. I'll show you that also. One of this is this also. So I'll give you 2 more assignments. So one is Ubuntu installation and then another is PowerShell. So we'll do that. So this one, okay, should be very easy for you, right? It gave you the thing, and you know, I don't want to give assignments which you know, spoil your PC, right? So you take the screen shaver, but you don't need to enable, you know, the option, different options. Tristan is here. So, and if you, for example, you put the remote desktop in this exercise, you undo it later on. Okay, if you don't want the remote desktop to be enabled, because hackers can join your PC if you enable the remote desktop, right?
Okay.
And also, they have a PowerShell. So if you don't give remote desktop, if you enable the PowerShell, then the hackers can come to you. So start here. So, there are two buttons, right? Left click and right click. So, and settings, right? So go to the settings.
Settings.
Yeah, go to the settings. It's telling you here very clearly. This is one of the best, compared to all other products, or this product guy, whoever wrote down, he made it very easy for people. So the other ones are not this straightforward, you have to really do something. So personalization, and then screen lock, and then screensaver settings. Screensaver settings are here. And then you select what you want us to do.
Photos.
Photos. And then you do the settings 5 minutes, I think, right?
5 minutes. Yeah.
Thank you.
And click on
And then you put the resume on for display. Click OK. That is done, right? Isn't it? So go to the now again to the system, and then do the remote desktop enable, right?
Yeah.
Go here now. So system. Do you see remote desktop? Yeah, the remote desktop is here. So enable it, right?
Mm-hmm.
That's all you need to do. Confirm. That's done. So another one you want to do is enable the Wi-Fi adapter, right?
Yeah,
Wi-Fi adapter, network adapter. So start. Yeah, I need to create a folder in the File Explorer. Go to the File Explorer here, and then select this PC or D drive you want to take, right? He said that D drive, and then D drive, and then create a folder in here, right?
Yeah. No.
So new, and then folder, and then change it to reports, right?
Reports.
Should be very easy. Reports, and that is done. Another task, network adapter, you need to go. So internet settings, right? I can close this one, go backwards to the system. So network and internet working, right, isn't it?
Mm-hmm.
So now we can do the network adapters.
You have to click on the change adapter option.
Yeah, change adapter option.
It's on the top.
Yeah.
The first
Yeah,
one.
first one. Yeah, that's correct. Thank you, Anna. So now you right click on it and then enable it. That's it, done. So now you can score it. So that's it, so done. So it's not that complicated, very easy. I'm pretty sure you will all do well. So the next one. Next one is what? Change Windows setting. I think it is a duplicate. So you need to do the screensaver. Again, I don't think I need to play the video, right? Because if you want a video, yeah, it's the same thing. So
In this scenario, you're configuring some monitor settings for your computer. First, let's change the screen resolution. Right-click the desktop, then click Display Settings. Change the resolution to 1600 by 900, then click Keep Changes. When you're done, close this window. Now let's adjust the screensaver settings. Right-click the desktop, then click Personalize. On the left, click Lock Screen. Then scroll down and click Screensaver Settings. Change the screensaver to ribbons. Change this number to 10, which will make the screensaver appear after 10 minutes of inactivity. Check this box, which will require the user to log in before they can access the computer. When you're done, click OK.
So very easy actually. So so 1600 by 900, right? So I will right click this settings, go to settings, and then display settings in the system here. So, and then go to the screensaver. Either way you can go, right? You can go click on the desktop, just like you did. You can do that also. So, or you can go through the system. So now screensaver settings are down below here, I think, right? Yeah, display. Yeah, display settings, right? You don't want to really change it to 1600 by 900, right? Isn't it? I think keep the changes. So display resolution is changing now. So now I will go to the screensaver, right? The screensaver settings. So go back again. So personalization is a screensaver, right? So lock screen. So go down below. Screensaver settings. So and change it to this time ribbons, right?
Yes.
Yes,
Thank you, thank you.
in 10
So
minutes.
10 minutes, yeah. And then check mark it here, and that's it. So we did it. And so we did it, and that's it, score it. So the next topic is like explore iOS. Explore iOS. Apple iOS, right?
In this lab, you'll explore several iOS settings on an iPad. We'll use the mouse in the lab, but on a real iPad, you'd use your finger. Most device settings can be found by opening the Settings app. At the top of the screen, we can see the name and email address of the device owner. At the left, we can see the device's Wi-Fi and Bluetooth status. To view information about this specific device, click General, then About. This page shows our storage capacity, version number, model number, and other device-specific details. If we scroll down this list, we can see other settings options. If we click Mail, we can adjust settings for our email application, including how many lines to show in a preview and how to organize messages. We can also see our settings for Safari, the default web browser on iOS. On this page, we can set our default search engine, configure our favorites, and adjust security settings.
Good, good, good. I think now we can do it now. We have to answer the questions, I think, right, in this mainly. So it's asking the questions here. We just have to answer them. So what is the email address of the owner of the iPad? What is the current status of the Wi-Fi? So click on the settings here, right? So go down here and click on the settings. Most of the settings are found here, right? So I think right there you find the answer for the email address of the iPad owner. So Levi's, right? Okay. T Levi's is the address. So T Levi's is the address. Okay, so one question is answered. I just put this back again. So now if you want to go to the general, I think you will be able to get this.
We
No
can enter
status
the
is
Wi-Fi. We can enter the
yeah,
Wi-Fi. too.
Wi-Fi thing, not connected. And the Bluetooth also is on, right?
Yeah.
So Wi-Fi and Bluetooth. Wi-Fi, thank you, Steve. So not connected, and then Bluetooth is on. And then go to the general settings and which iOS version is there. So click on the general and you close this one so that you will be able to see it. So about, thank you. So now 11.4.1, the version number. 1141. That's a version number. And he's asking you the mail settings for how many lines. So
My
go
guess.
to the, go back again here and go to the, scroll it up, right? So let me just pull it down here a little bit. And then mail is here. Click on the mail. So on the top, you see the number of lines, I think, right? 2 lines. You can answer the preview lines are 2 lines. Preview lines are 2 lines. Oh, we still have one more question. 2 lines. And then in the Safari settings, what is the default search engine? So go to the Safari. Safari is the Minyangi joining us. So Safari is here. That is a browser for the iPad, right? Safari, where is my Safari? It's here. Double click on it. Search engine is Google, right? You see that on the top?
Yeah.
Thank you, Steve. So search engine is Google. All right. I'm not leaving, easy ones also. I'm just giving you all the labs so that you get the feel of it. It's good, right? So done. So 3 labs are done. So the next lab is update the drivers. The next ones are coming in like BIOS settings and so on, which is good. BIOS settings were done. Explore iOS was done, right? And the next one is update drivers. Update driver. I think maybe we played the video before.
In this scenario, you need to update the drivers for 2 of your hardware devices. First, we'll update the driver for the network adapter. We have the driver saved on a USB flash drive. Switch to the back view of the tower, open the Storage Devices menu, and drag the flash drive to an available USB port. Then click the monitor to access the computer. To open Device Manager, start typing its name into this search field until it appears, then click it. The Device Manager shows you all the hardware connected to the system, grouped by type. Open Network Adapters, right-click Realtek 8169, and select Update Driver. Since the driver is on the flash drive, click Browse My Computer for driver software. Click Browse, then scroll down and select the flash drive. Click the Drivers folder, then click OK. When you click Next, the computer will install the new driver. Next, we want to update the drivers for our scanner. Open the Imaging Devices list, right-click the name of the scanner, and select Update Driver. This time, we want to search automatically for updated driver software. Windows automatically finds the new software and installs it for you.
Time to time updating your drivers is one of the best practices, right? So because if there is any bug or anything in the old software, so these people update it, right? So time to time updating your drivers is a good thing to do. So some of the software systems will be able to identify, there is normally a support assistant, right, for your computer. So if you have the support assistant software, it will identify all the drivers that are out of date. I think I would recommend you actually to use the, support assist rather than any other third-party software to tell you which driver to install. So, support assist will certainly get you the right drivers rather than any hacking, right? Malware or anything. So now what we do here is go to the back side of it and then make it a little bit bigger. and then take this storage devices here from here and then put it in one of those USB drives, right? And go to the front view, go to the click on this Windows to start. So now I right click on it to find out the device manager, right? Device manager. So right click is going to get you a lot of things. You can even write down on the, what is that start button and keep writing device manager. It will get you the same, right? Any program which is in the Windows, you write it down in the start button, you'll get that. So device manager will list all the devices. So, and we wanted to actually have network adapter and scanner, right? So Realtek, right click on it. So update driver and take it from the computer, chip drive that we have, right? So, and browse. And then we have, I think in our,
E drive, I think.
jump drive, E drive, right? So thank you for that. So go to the jump drive. So in the drivers folders we have, right? The driver is in the drivers folder. So in that, so browse it and then update it. Go to the next and it's going to be updating it. Good. So time to time is it's a good practice to do this, right? So, and imaging devices, which is scanner. So mouse tech scanner. This one we would like to do automatically. Search from the, normally we use this option, right? Because unless you downloaded the Windows, downloaded the driver from the website, and then put that into the flash drive. So that's it. I think we did both the devices updated. Okay, the drivers are updated. So which is done now. So that's all I posted, 4 of them, right? So I'll post 4 more or 3 more or 4 more in the next class. So we will go to the Vanier Omnivox. I think we have done already we already completed this one of the labs, right? Which is Explore Windows. So that should be easy for you. But like I told you, don't keep the remote desktop unless you want to keep the remote desktop, right? Even if you take a screenshot and then put it back again, it doesn't matter for me. So go here now. I will lecture the lecture notes. I'll show you the other one, right? Other one is the runnable interface processes. Lab 3 is Explore Windows. Lab 2, we have a lab 2. I'll go through it. I can do that also and then take the break after it. It's scheduling, So task scheduler. So I gave you some lecture notes also to watch if you, read it, right? So a task scheduler in Windows is going to allow you to actually schedule on a timeout basis or a periodic basis some automating any task, routine task to be done, like a disk cleanup or something. Okay, in the start the control panel, administrative tools, okay, and task scheduler. Okay, and what you do is task schedule app, run task scheduler app. So I gave you screenshots here, so you'll be able to read it very easily. So this is the task scheduler, right? And then you actually see it. Okay, create a task. You can click on the create task and then create a task. Okay, just clean up or anything. That's what I do. You can do anything on a timer basis, right? In this exercise, I made you to actually, I think, disk cleanup, right? So create a basic task. Okay, and click on the create and click next. Create a basic task. and click on the, disk cleanup, right? Disk cleanup. So periodically run. Okay, and a specific conditions, man. Regular file cleaning. Next. And next, set up the timings, and that's it. Set up the timing and it's finished. Start the program. And cleaning.exe, cleaning manager.exe. So that's what is going to be executing on a timely basis. Regular file scanning and finish. That's all you need to do. Okay. So let us try to do it. Start button, right? Let me take the lab beside me here so that I'll be able to with you. Okay. So what you want to do is click on the start button. Okay. And, control panel, you write down control panel. You write down control panel, your control panel will come and double click on it. So control panel is getting executed, right? Administrative tools. I think, so you have the administrative tools here. No? System, right, administrative tools directly, because it's the older version of it. So that's why I see it. Even if you write down administrative tools. So Windows administrative tools, look at that here. So I go here directly, because in your system, you'll probably be able to find very easily. So, and then what you have, task scheduler. So go here now, task scheduler is right here. So there are different ways of actually going and navigating it. So it's not really like, don't worry, there is no one way of doing things, right? Okay, no one way of doing things. So create a basic task. Okay, so that's what you wanted to do, right? So create a basic task. So then what you want to do is you want to name it as regular file cleaning. And then do some description as you like, right? Whatever is given to you here. So he says this basic task runs regularly to clean up your junk files on my PC and laptops. That's what I wrote down there. So you write down that, and then actually, you understand, right? So, and then you go to the next.
Yeah.
So go to the next. So what did we say? So we want to do weekly. Click on the weekly, and it'll ask you the time of the week, right? Obviously. So whichever time you want to set up here. Okay. So first you set up the time, and recur every 1 week on a particular day if you wish. I put in the Wednesday, I put it there, right? I put on Wednesday, I put that. You set it, select this, and go to the next. So start the program, right? So when you start the program, then you want to do, so you need to select the program which is in the, so the start program means is going to ask you which one to run. So now to browse, you browse the cleanup, system. So go to C drive here, right? Go to the C drive, C, and then what you have is Windows System 32, Windows. It's bothering me here. Windows, double click on it. System 32. Okay, so now, and then clean manager, right? .exe. Go up all the way. Don't have it. System 32. Clean manager. If you find it, let me know. I don't see it.
Just use the search bar.
Yeah. Good. Thank you. Good idea. Clean manager. CLEAN, right? MGR.
I showed before. Go back. Just there you go.
Yeah, this is what it is. Thank you. So double click on it or open. Open. So good idea, Steve. So open, I got this now, clean manager.
That was Charles.
Charles, right? Sorry, yeah. Thank you, Sir Charles. So I can't see your names though. That's why, when I'm doing the thing. So very good, Charles. So then now, go to the click. Maybe I should write down in my thing, right? But you know it. Maybe, if you don't see it, you actually click on the search button. So if I note that down, it will be easier for you. But anyway, now that you know, click regular file screening. I think finish, right? That's it. Okay. So if you don't want to really start, don't finish it. And then you actually, take a screenshot of it and then cancel it. That way you don't need to really do if you don't want to. Because it's going to bother you every, or undo it after, right? You can take it off. Okay. So that is assignment here, another assignment. So 2 more assignments. You want me to give you the 1 more assignment? I think probably I can give you. It has a step-by-step instruction and a video also. So it'll give you, you'll finish it, along with it by 31st. I think I gave you 31st. So let me give you that also, so that you will have this assignment 3, 1 more assignment. So you'll be easier for you. Okay, you all agree with me? Because we can finish early if you can do. Not finishing early, but I think it'll take enough time. So the list of assignments, and this assignment is installation of Ubuntu. So go to the list of the assignments here, and I post it. So this one I'm asking you because you need this anyway for one of these topics, Linux, right? So instead of waiting till the end of the system, I can ask you to do assignment 3 is Ubuntu. So I'll just make it. It give you enough time. So update drivers, install Ubuntu. VBox and Ubuntu. So let's look at it also. Look at it very easy. So install the VBox from the Oracle. So I gave you the website here. Look at that. And I gave you a YouTube video also to install Ubuntu. So he'll tell you exactly how to do it very clearly. So you can do it very easily, step by step. Ubuntu. Okay. So only you do once, right? Unless you want to install in your PC, right? And Ubuntu is a Linux operating system, will run under your Windows, right? So which means that VBox is a software that makes your virtualization, right? Isn't it? So you can keep anything, any of the virtualization for running different operating systems under the same operating system, right? like VMware, virtual machines. So, Oracle VBox, that's what you're going to install here. And then Ubuntu, so that, you'll have, PC under PC. Okay. So that's, this is the one which I'm going to post it also on the web page. Go to this assignment number 4, right? I'm going to post that also. Since those assignments are very tiny assignments, you can do it very quickly. This one probably will take an hour or something, right? So, and you have to do in sequence and series, and then you need to have enough memory on your PC. So, okay, assignment 4.
So, Professor, we are doing this assignment now?
No, not this one. Now I don't do it now, but I'll give you enough time to do it. I don't understand your question.
No, because I think I understand wrong. Like we are doing this and you call the day, I guess. I finish early, no?
So we have a SEM 2, SEM 3, and SEM 4.
Yeah.
Okay.
Assignment, these are very fast, my friends.
Yeah, it's okay. Yeah, just confirm.
Yeah, for sure. I'll give you enough time. So these are very fast, nothing to worry. And even if you want a little bit more time, let me know. I'll give you.
Okay. Thank you.
No problem. Linux assignment 4. Where is not here? 5 installations. 5, 6 lazy commands. Assignment 4. Lab. Maybe in the download side. Yeah, this is the one. Assignment 4. So submission deadline, I'll put till the end of the month. So accept the late assignments. Whenever you get the time, just do it, right? So don't wait until the last minute and then you forget and come back and ask me for, oh, no, I didn't do it. So that's too more work for me. So assignment 4 is given there, so submit it. So it will post it. So that, let me see if what I posted is the right one, right file. Oh, I didn't attach the Explore Windows file. Looks like I didn't attach it here, right? What happened actually? Supposed to be attached. Explore. Choose the file. I posted over there, I think, right? Take the screenshots. Screenshots and submit it. I think I actually wrote it down.
What do you mean the file? Do you mean like the directions on what to do?
No, the screenshots.
Oh, no, you didn't. It was
I
just the directions, but there's no screenshots for the Explore windows.
Yeah, you need to, when you submit it, you need to really do that, right? When you take a screenshot and submit it. I think I wrote down in the file I posted, but you know it now, right? So I posted it. So posted the file, at least you have the file now. Let me see what this one is. Is it Ubuntu? No, I think it's the wrong file. I posted a wrong file, right? Lab 3. Oh, assignment 4, yeah. That's okay. Assignment 4 should go down. This one is Ubuntu installation, so it should be 2 lines in there. Virtual memory. Sorry for that. I think I posted a wrong one. Okay, all right. I delete it. Don't take this. But it's okay if you did it, but I don't want you to confuse. Okay, I don't want to confuse you. I'm deleting it. Okay. It doesn't let me update the file alone, I think. So if I go to the main page and I take that other assignment. So I can actually, that's virtual memory, allocation of one partition. Like for example, you remember extending the swap page you can increase the swap page. That's what it is. The other assignment is. I think last time I made them to do, and this don't need it. It's okay. So go here now. Go to this the one I posted here. Alexander is here. So I'll admit and give him attendance. Assignment 4 is here, installation of VBox, right? I think I actually downloaded it here. So if I go to the downloads button, I may have no. So let me just go here and then download it. So move this one aside and click on the download button. So it'll be in a downloads assignment installations in the download. So go here now, assignment 4, rename it. Okay, assignment 4, installations. All right. So now I have that with me. And then I will post it now in the assignments folder. Create a new assignment, assignment 4. Basically, it's installing Ubuntu. Select the file. And we go to the downloads. And select this assignment 4 installations. And put this into assignments category. And then post it as of now. And make the deadline till the end of the month. And accept the late assignments. Doesn't mean that, you are going to be, submitting late, right? So you submit on time. Good. I think all the things are posted now. Let me check again. What I posted is the right file. Yeah, good. So now you have it. All right. So anyone has any questions or attendance? Some of you came late attendance, right?
Yes, I came late, sir.
Yeah. I will give you today is okay because today is not time change day, right? So I go back again here to the attendance place where I'm going to read out names again, whom I marked as absent. So Amar is absent. Tristan is here, right?
Yes, I'm here.
Thank you.
Thank you.
And Alexander also is here. Yeah, Alexander? No? I see Alexander joining. Connor is here. Must be here because there's 34
Yes,
people are
hello,
here.
I'm here.
So Connor is here. So all of you are here. And Kunyu is here. Okay, all right. That's it. So take a break now. 20 minutes break. Yeah, 55. Come back at 55. Or 10. Make another 5 more minutes. So we did all this. Now what we do is we continue using that, what is that? We can start the new chapter, which is threads, right? So after you come back, so you will start this new topic. So thread programming and not programming, but the programming also in there. So process is completed. So threads and concurrency we can do. And the CPU scheduling is halfway through. We'll finish that also. And that's what the plan is. So later on, that because we are doing CPU scheduling, there is a chapter on the CPU scheduling. It will become very easy for us. That one can go very fast. And then the main memory will take us some time. Okay, the topic main memory takes some time because there are algorithms for allocating memory and the segmentation. It could be a little bit challenging, and segmentation, paging, and that kind of stuff there. And then we have Ubuntu coming up, and then PowerShell, and that's the end of the story. Okay, and if you have more time, I'll teach you a little bit more Linux. Okay, good. So maybe you take a course on Linux separately again, right? So there is another course on Linux operating system. So Linux command line interface, I think they teach most of the time. Okay, so we'll come back at 10 o'clock, right? Okay, yes or no?
Yes.
So I'm just pausing the recording.
Thank you.
Welcome. So pausing the record. So when I come back again, just remind me that we need to continue. Thank you. Hello, everyone. Hello. So we are here again. No problem. It's okay, Alexander. I know Monica is Connor, I think, right, Connor? No, Monica. All right. So I'm actually recording right now again. So let's continue again. So where we stopped off. So I'm sharing my screen again with you. So go into the thread programming, and then we will go to these algorithms and then finish it off the class, right? So I start this thread programming to at least to give you a kickstart for you to be able to read that chapter. So it's a very interesting topic. Thread is basically a piece of code, right? Runnable task. It'll be very interesting for you to know this. So threads and concurrency. So there are copies and some demonstration. I'm going to make it here. So I'll explain you. You want to understand, what is a thread and so on. We will understand. So thread and concurrency. Okay. So basically, thread programming will enable multi-core programming. So you have multiple cores. Keeping those cores idle is not really good thing to do, right? So which means that you have power, but you're not using the power because you cannot use the power. Because your program is not conducive. Program is set of instructions. So they are executed in sequence. So if they can only run on one core, cannot run on multi-core. You agree with me? Hello? So you write a program, there is set of instructions. So which means that those instructions will run in sequence. So in sequence, one after another, which means that, cannot run in multiple cores. So you have multi-core, the quad core, what's the use of that? You're not running. So you can have same program though, but you can have multiple programs running on multiple cores, right? So, but you are only one program to run, then your multi-core is not really running. Obviously, if you are actually multiple programs are running, then you can put in different cores. So running one program multi-core is like multi-threading. So multi-threading models, thread libraries. So already available thread libraries, implicit threading. So implicitly you will be able to enable the threading. So threading issues, what kind of issues you have. So these are the topics content today, right? We'll look at operating system examples. So notion of a thread is a fundamental unit of CPU utilization. Okay, so that is the basis of multi-program, multi-threading. So API is, API is what? Application Programming Interface. So it's a data structure. Thread is a data structure. Just like socket is a data structure, thread is also a data structure. Okay, so you have different ways of actually running the thread libraries, and there are threads and thread libraries. Okay, so explore several strategies. So explore several strategies, and then you look at implicitly, doing the threading, not explicitly, implicitly, right? Okay, so there are different structures to be able to run thread programming, because it's a API. It's a API. Okay, so API means application programming interface, right? So every operating system, okay, will have different APIs. So POSIX, Windows, so and the Java thread libraries. So those are the things that you have, right? So operating system support for thread in Windows and Linux. So Windows and Linux are more popular operating system, right? Okay. So most modern applications are multi-threaded applications, because the designers these days actually support that. You see what I mean? Designers support those, thread programming. So update, display, fetch data, spell checking. So that means these are all different, methods in a program. In a program, you have set of methods. Answer a network request. So remember, I was talking about server form and so on. So spawning a child process. So and process creation, heavyweight, and thread creation is a lightweight, because thread is a piece of code. Thread programming can simplify code, increasing efficiency, because multi-kernel, like kernels are generally multi-threaded. Okay, so client and server, look at that, client and the server. So spawning a child process. So child process is like here, thread. Okay, to actually serve a service request. So actually it's listening. Pardon, go ahead, please.
What does the arrow back to the server mean?
Because I'm reminding here, I'm spawn a child here, I'm coming back again, resuming additional client requests. Because here, right, the server is in the listening port. There is a listening port, right? The port number that is published here is a listening port. It opens the port number and then waits for the service request, right? Remember, I did show you in the demonstration.
Yeah, like when you did with your three IDEs, three Eclipse.
Yeah. So when we were doing Eclipse, so the server was up and running and waiting for listening on the port. Listening on the port. So in the example I did synchronous. I did at the same time, not really like So one thread was running for, for all service requests. But again, what you can actually do is you can put that run as a, you can create another task of servicing a request, and that can be a thread. So each request can be a thread. So so that means you're listening, spawn a child, and get back again listening, spawn a child, get back again to listening, spawn a child, or a thread, right? So each one will directly go to the client now. The server is, to him, that the client, he knows that he is in the session with the server, but he's running actually to a child process here, or a different process. It's very interesting, right? So that is programming you can enable. We can even modify that program that I actually made it. I can modify that and to create multiple threads to handle. That should be, it should be very easy. I created that one just by modifying the, which is the published code. That, they didn't do for, inventory management. I made it myself, like a stock market, inventory management, and so on. So basic code is the same code, like I told you, handling the socket. So again, the same story. The thread programming is also standard programming. So it's easy to actually modify that and create another thread. So I actually created the thread in the main program itself, if you remember. So I can show you. So, but you can actually run the program without being main. Let me show it to you. I think Eclipse 2020. So you don't need to do, thread. You can still have socket programming is one thing and thread programming is another thing. Both are different. Socket is for the service requests. Thread programming is concurrent execution, parallelism, concurrency. So that's what you advantage that you have with the thread programming. So a thread is basically a method in Java, and you can actually put it as you wish. So in PC2 programming course, I'm teaching those topics. PC2. I'm teaching those topics here, right? I think is inventory server code here. So if I go here, I'll show you. The main program is down below here. Look at that. So, I'm creating a thread. See what I mean? Inventory server. So technically speaking, right? You have to write down inventory server. You can even write if you want here, inventory server. Control C, Control V. No, it doesn't work. Control. Yeah, it works. So inventory server. They will teach you, I think, in toward the end of the PC1, they will teach you. See, look at that. So this is basically, I'm not creating a thread. I created a inventory server object. Okay. Like scanner yes equal to new scanner. Remember, I must have studied. So like that, I created an object. But the thing is that this inventory server, I made it extending the thread programming. So thread, see that extends. I can take out this and then do it. But if you want to take out this, I have to, will the run into this is, can you tell me what is the name of the method?
Run.
This method, run. So run is a very special keyword method. So there is an interface called runnable. And thread is actually, implementing the interface, runnable. So inventory server here is extending the thread. So that means actually data structure which is going to be created is going to be who is the parent of the inventory server? Extends means what?
Inheritance.
Inheritance. So the parent is thread. and the child is the inventory server. The child is inventory server. So which means that if you create an object of this, right? So thread is already created. Whether you need it or you don't need it, thread is created. So that means I can actually take this the object and extract the in server. If I take this, right, for example, so it will automatically keep thread in server, right? In server T port number. So duplicate variable. I'm declaring a thread. So you can put T equals to. I'll put thread equal T1 equal to T1. Okay. So now I'll start the 3-1. Or change it. I won't really take out this one here. I will keep the same T here, but I'll say inventory server is 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 inventory server. So that is the, see here, inventory server. So what did you do, sir? What I did is I took the object of my thing and extracted the a thread, pointed to the thread or reference to the thread, and then started that. So it'll run perfectly fine. They'll teach you inheritance. Then at that point of time, you'll understand very clearly. When I started this right here, so what actually happens is this is going to execute this interface here. This one. So it's like a thread now. It's running like a thread. But what I can do is I won't make this one like a thread. Okay. So I can be listening. So when you accept, for example, look at the accept here. Look at the server socket accept. You see that here? Okay. At that point of time, the remaining code, I can actually make it like a thread. Another thread. And then run that. Okay. So that way you will be able to execute as many as you want. Okay, sir, no problem. Okay, so going back here again. So thread programming makes it easy for you to actually make the load balancing. That means, you can actually put multi-core, multi-processor, multi-core programming. So data splitting, you can split the data into 2 parts or multiple parts and then actually give the ownership. Okay. And divide and conquer your programming activities so that you can assign a particular task to a particular programmer. Testing and debugging is also easier, parallel concurrency. So there are a lot of advantages of thread programming. Task parallelism, that means tasks are running in parallel. Data parallelism, that means, data, subsets of data. Data, big set of data is actually created into subsets and assigned to different parts of the programs, right? So this way you will be able to allocate, the responsibility, distribute the responsibility across programming units. So number of threads are increasing. So you have to have, some kind of support, right? So CPUs have the core as well as the hardware thread. Hardware threads are executable threads. Okay, 8 core, 8 hardware core. So thread here basically the kernel threads are hardware core. So single core, all of them are in sequence. Look at them. They're executing in sequence. Parallelism, because it's multi-core, dual core here. So T1, T2 are executing and T3, T4 are assigned like that. Okay. So when you are actually multitasking, look at here. So T1 and T1 came again. Can anyone tell me why T1 again, T1 and T1 again here? Scheduling, right, isn't it? Because of the scheduling, round robin scheduling, round robin scheduling, round robin scheduling. Okay, so round robin scheduling T1, T2, T3, T4, T1, T2, T3, T4 like that, right? If it is a single core, multi-core, you have multi-core. So single and multi-threaded processes. So single threaded process, like if you don't write anything, it's like a single thread. Okay, so multi-thread, thread programming is enabled here. So multi-thread. So that means you're dividing the code into different parts here, right? Actually, so the data is actually, the data here and the files here and the code all are available to all these multi-threaded one, but the register set is different for each core. The different registers have different stack pointers, different memory allocation. So that's what makes it unique. Okay, so okay, all right. So parallelism. So Amdal's law. There is Amdal's law. Okay, the parallel portion, right? Parallel portion. Serial portion is known like a percentage, for example. Okay, so serial portion is 25%. Then parallel portion is application is 25% parallel portion and 25% serial portion. Moving 1 to 2 cores. So then the speed increase is 1.6 times. Speed increase is what? 1.6 times, right? 1.6 times. So one process, one core to dual core, n equal to 2, right? Can you compute it? Can you compute it? Whether you're getting it none or not? Yes equal, let me compute it for you. What are you computing, sir? So I'm going to take that, yes equal to 25% and n, and then n equal to 2 and then compute this expression. Okay. Maybe it'll be multiple choice question in the exam about Amdahl's law. One second. Okay, so yes equal to like 25%, right? How much is the yes? 25%. How many cores you have? N equal to 2 cores, right? Isn't it? Can you actually compute that expression? So let me make that expression for you here. So 1 divided by yes plus, yes is what? 0.25 plus, and 1 minus s is 0.75, right? Is it not? I can even write down just directly because, okay, right? Let me write it down. Like 1 minus C3, so that you will change it, it will automatically do it for you again. 1 minus C3 divided by n. So the whole division right here. Okay. Did I do it properly? I think the division is done. That's it. So 1.6 times. Do you agree with me?
Yep.
The speed up is 1.6 times. If you know the serial portion of the code, okay, and that means reducing this. So let's look at here. So if you reduce the serial portion of it, for example, 0.1, see here it increased now, right? Isn't it? The speed is increased to 1.8. So 0.05, 5%. So 1.9. So it's going to increase, right? Increase to maximum 2. Cannot be 2, sir, because unless you put only one, nothing on the other one, but nothing on the other one is not parallelism. So you need to keep at least one part, some part of it in another one. So user threads management and kernel threads management. So kernel threads are supported by the kernel. So user threads are managed by user thread library. So POSIX P threads, Windows threads, Java threads. So 3 primary libraries and several operating systems, right? You have so Windows operating system, Solaris operating system, Sun Linux is called Solaris, right? And Linux operating system, True 64. There are plenty of Unix versions, variants, and Mac OS. So when you are assigning, tasks, there could be multiple threads can be assigned to one kernel thread. One kernel thread means like one core. So many to one to one, many to many. So give an example, sir. Look at that. So many to one. So many user threads are assigned to one kernel thread. So that means they will be executed by that single thread. It's like a core. So many user threads are mapped onto the single thread. So one thread is blocking, causes all the threads become blocked, right? Isn't it? So one thread is blocking, that means it gets stuck, all other threads get blocked because they're all assigned to the same kernel thread. Kernel thread is the one which is executed. So it's like a service provider. You understand me? So if you go to, a service counter, for example, and there's only one person working, that means you have to wait for, when you go to bank, especially, you are waiting for one guy wants a lot of work to be done and then you're all stuck. Thanks to the scheduling algorithms. So few systems currently use this model. So Solaris, green threads, GNU portable threads. So implementations are there. So 1 to 1 here. So it's fastest. So each user thread is mapped onto one kernel thread. So that means like, you have separate luxury of computational environment here. Creating a user thread creates a kernel thread also at the same time. So more concurrency than many to one. So number of threads per process, sometimes restricted. Okay, due to overhead. So that means when you are actually, running a program, so you are not advised to create too many threads at the runtime, because the thread scheduling itself is a challenge here, because you have to allocate one kernel thread to each, like a quad core, you have 4, or each core. So have 2 kernel threads. Normally, each core can have 2 kernel threads. Windows, Linux, so that means quad core is going to have 8 kernel threads. So allows many to many. So any one will be assigned to any one of them, many to many. Okay, so that's efficiently using this, this is like a queuing system. So it is more efficient also because you will be running them any one of the threads which is available, kernel threads, right? So I'm not going to ask you examples because you won't remember them. So similar to many, okay? So what do you have here, sir? So 2 level model, both are implemented in this model. 1 to 1 whenever you require, many to one, right? So assigning. So thread library providing the programmer for the API to creating and managing threads. So thread library, library means set of functions, set functions. Okay. So thread library provides programmer API to creating and managing threads. So and the library is entirely on the user space. kernel level, you know what that means, right? So pthreads, POSIX threads. So IEEE standard API, thread creation, synchronization. Synchronization means comes back and joins the main program process, right? When you are spawning a child. So it's excellent, you know, works perfectly fine. Operating system provided features. These are the operating system features. So now you look at here, I am going to show you one of them here, right? So obviously this program is, can you tell me what is the programming language that you are looking at right now?
C.
It's C.
Yeah, it's a C. C files are .h files. Look at that here. ST standard IO. So, you know, import, IO library in your Java. So that is standard IO here in C. So pthread.h. So .h files are the definition file. Normally, you know, you don't put code in the .h files. All variable declarations are kept in the .h files. Usually, you don't want to create too many variable declarations here in the regular C code file. So all variables are kept in a different file called .h file. And most often we keep data structures in that .h file. Data structures, definition structures. Okay. So and any run, you know, in integer, any variables you can always declare in your regular program. Yeah, look at that here. So these are global variables. Anything that you write outside your main are global variables in C programming. In Java, there is no global variable concept. Why? Because everything starts inside a class in Java, right? Your program starts with a class. C and C++, your program doesn't have a class. It's only just the main program, main function. Main function, one of the files, .c files, has the main. Okay. You know, I wrote a program without main because I will be running that through another program where this program is going to be used. Okay. So here, what is it trying to do? Actually, he's creating a thread. Okay. He's creating a thread here. So attributes, setting up the attributes. And argc not equal to 2. What does that mean, sir? So for the main, this look at that argc and argv here. This is the pointer to the set of variables. Okay. And you have the number of variables here. They are not 2, then he's going to give an error, right? -1, it returns. Standard error. Flashing an error. Okay. R is the first one. Argv first one is less than 0. So that means, cannot be. So don't worry about this. Okay. The program. All right. So, if you want to convert, character to an integer, right? So this is the function that you can use, Adriano entering. So this is a function to convert a character to an integer. After you convert to the first one, you convert it to an integer. So, and then, but you have other methods, no? Okay. So in Java, what you have, all arguments are strings. So that means, integer, parse int, and provide the string, it will be able to convert to an integer in Java, right? Okay. So setting up the threads and, sum equal to sum. What is trying to do? Actually get the value. So join means thread is coming back. You fired a thread. Okay. So which is actually runner. You're executing a runner. Runner is this code here. So it has a value called sum. And this is a global variable. You understand me? This is I'm showing it with you. Do you see my cursor hovering?
Yeah.
Yeah, thank you. Because I either write it on the pen or I'm hovering the cursor. So this is a global variable. So that means global variables are shared by all functions. Global variables are shared by all functions. So that means if this function, okay, is using that, setting up the value of the sum to 0 and then doing some, you give an upper limit, okay, one of the parameters that I gave you here. So converting back to an integer and a value is upper. So that means, for example, upper can be 10, for example. So then, so I equal to, so, starting from 1. So 1 plus 2 plus 3 plus 4 plus 5. So sum is going to be arithmetic sum. And then once you finish this, you exit. When you exit, right? So it joins back again here. Look at that here. Pthread join. So he create the thread here. Okay. And he's waiting for the thread to exit. So when I, for example, if I send my son to a grocery shop and then ask him to bring some items and I'm waiting for him. Do you agree with me? He's going and doing the work and I'm just waiting for him to get the work done. And then he join back again. So, okay. So join. All right. And then after that, I will print whatever he got. So it'll do the work. The beauty of it is you can run in a different core. So number of threads is 10. Define. This is the one way of defining. Okay. The notation, all capitals. What is it? Did someone teach you?
Is that a
Constant?
final?
Constant values. Yeah, final. Yeah,
Mhm.
constant is final basically. In Java, people say final, but it's basically constant. But this constant is not really like a variable constant. It says, you see the hash here and define here, which means that this is not really a variable. This is a symbol. What is the difference between variables and symbols? Symbols, are not translated to any addresses. Variables are translated to addresses. This value here, right, is a compile time preprocessor variable. Preprocessor means what? So, before program is compiled, right? There is a preprocessor comes in and looks at all your code. Any defined, look at that here, it'll be replaced by this 10 here. Is as good as you wrote down 10. So, and before even compiling, this number is replaced to 10. And then he will compile that code. It's not really variable. It's not really like a, constant that you use in your programming. But you can use it as you have it. But preprocessor will replace them. The advantage of doing this is you can only have one place to change them. So that means defining 10 in equal number of threads. So now wherever you see number of threads, it will be replaced by 10. So I want to run this as a separate function. The thread runs in this separate function. Thread is running in this separate function. So that means you see the main program is here. The function is here. The name of the function is summation. You understand me, right?
Yeah.
Name of the function is summation. Okay. He must have defined, D word and but normally we write down integer sum, right? So he's actually data in shared by the threads. So T word is the defined as a sum here, and okay, so and this is the main here, so it's actually looking at if the where arguments are not enough properly done, then you will not be able to firing it, otherwise you will fire. So this is a place where you create the thread based on your input variables proper input variables. So that means what to fire as a thread here is known to you, and then you're actually firing that as a thread. So create thread in Windows environment, right? In Windows, create thread is going to create thread. Okay. In Java, I just created thread directly. So here, what you're trying to do here is, so p thread create, POSIX thread create. So you know the attributes. Ampersand means address of attribute, address of TID. Ampersand means address. Okay, so don't worry. I know that it's not really like you need to worry about it. You don't need to. Okay, so like I told you earlier, right? There is an interface called runnable. You understand me? The interface called runnable. Public abstract runnable interfaces normally are keeping, they don't have methods. They only have abstract method. Can anyone tell me what is an abstract method? Where the implementation is not available here, it's called abstract. Okay, you understand me? Usually what you have, so you have, let me bring the pen, because I used to have 2 pens. What happened was, in my classroom, I forgot this, the XP pen, and I lost it. I went back again, didn't find it. So that I'm only left with one now, so I'm bringing one. So I used to keep one with for my classes, another for my home usage here. I need to buy one more. So this is $100. So I'll just stop here and then come back in 1 second. In 1 minute, I'll come back. So whenever you have right here, for example, so you have a run function, right? Function. So function, basically you have a curly brace here, a curly brace here, and write the code. So when you don't have this code, what to write? So just put a semicolon there. That means the method, I don't know how to write it here at this point of time. So then you write down abstract. The abstract is a method that where the implementation is not known at this point of time. What does that mean, sir? So implementation can be known to you later on. So for example, in an inheritance hierarchy, a class is here, another class is here. So this is the parent class, like a parent class. So, and this is the child class. So parent class may not know how to run. Understand me? Want me to give an example? Example is animal. And this is a bird. Can animal be a deer or a dog? Yes or no?
Yeah.
Dog. Can it be frog? Yeah, frog. So if I write down, okay, walk, a method called walk. Okay. So do you know how to write walk without knowing what the animal is? No, you cannot write. So that walk will become abstract method. But you know, dog, how it walks, the bird, how it walks, and the frog, how it walks. Sir, bird doesn't walk, it flies. Okay, walk means fly for us here. So you write down, okay? So the code for flying, whenever you execute walk here, so it'll execute the walk here, which is like flying. So this one is frog is going to skipping and dog is going to really walk. So this is called polymorphism. What is it called?
Polymorphism.
Yeah, polymorphism. Polymorphism means executing abstract methods. Execute this one, automatically it'll execute the appropriate method. The animal is a dog, it will execute the dog's method. If it is animal is a bird, it'll execute the bird. That is polymorphism. You understand me, right? Inheritance means what? Inheritance is here. Okay. So there is a tell me your name, tell me name. Tell me the name. That's a method. Tell me the name. So all these animals have names. Okay, you understand me? So the bird here is the dog here, the bird here, and then whatever, frog, whatever you have, all of them have names. You understand me? So name is right here. I declare right here the name. So tell me the name is a method, or get me the name is a method. Okay. So using this pointer, I can run this method. So that means dog, you create a dog, D equal to new dog. If I do that, of course, I'm going to put some variables in there, right? The name of the dog or something and so on. So D dot, tell me the name or to get me the name. So the get me the name is not inside the dog class. It is in the animal class. But dog is an animal. Bird is an animal. Frog is an animal, which means that you can execute the parent method by using the reference of the child method. This is called inheritance. Inheritance means, what is inheritance means? Executing the parent method using the reference of the child method, child class, child object. Okay. So this is object reference. So executing the parent method automatically. So, technically speaking, when you say D dot, tell me your name or something, that tell me the name should be existing here in the dog. If it is existing in the dog, no problem. You'll take the tell me the name in the dog. Okay, you can have tell me the name in the dog, tell me the name in the parent also. Also, you can have both. But which one will be executed? Okay, if you have the one in the dog, there is a tell me the name in the dog, then you will say tell me the name in the dog one. But you don't have it, then it'll go to the parent one. If you have it, then it'll execute that. So bird maybe doesn't have the tell me the name method in this one. This is called inheritance. Inheritance means going from the bottom to the top is inheritance. So polymorphism means going from the top to the bottom is the polymorphism. What do you mean, sir? So walk is an abstract method here, but actual walk is written down inside the child class. So when you try to execute walk, animal walk. So I can write down animal A equal to new frog. I created a frog as an animal. You can even write down, remember I did earlier few minutes ago, I modified the server method, right? Exactly the same way. This is the parent. So I can actually do the thread child if you want. Frog, F equal to new frog. I can write like that. And now I can write an animal A equal to frog. If I say that here, okay, it will automatically take the right pointer, right reference to that animal. So now you can run the animal A walk here. When you execute the method inside the parent class, it will automatically go down below because the method is an abstract method. That's called polymorphism. Okay, all functions inside a runnable interface are abstract methods because you don't know. So secretary doesn't know how to do the task. Manager knows how to do the task. But secretary knows, you know, what to do. So you need to use the run method here, right? Abstract method. And it is a runnable interface. You can rewrite your runnable interface if you wish. So now you take here. This example I'm going to demonstrate to you. Either today or tomorrow, right? Next class. I think today I can demonstrate. Okay. So look at here now. So can you tell me what is the name of the class?
Sum.
Yeah. So this is the beginning of this is the class. How many methods you have in a class? You know, what is a class? Can anyone tell me, please? Maybe they did not teach you yet, right? Class is a data structure. What is it? Can repeat? Someone repeat, please.
Data structure.
Yeah, class is a data structure. What is a data structure mean? Set of variables. API means set of methods are written down in there. So class is an API too. Okay, set of methods are there in the class. Set of variables are also defined in there. These variables are called instance variables. What are they called? Instance variable. Why instance, sir? Because object is an instance of a class. Object is an instance of a class. What is an object? Object is an instance of a class. Okay. So what does that mean, sir? Class is what, sir? Class is abstraction. Class is abstraction. Object is real. Abstraction means what? Something that you don't know.
Unknown.
Unknown. But it is known here. Let me give an example, sir. Student. Did you see a student? No. What are you meaning of student, sir? I don't know. Student. Oh, student can be described. Okay, class, student. Okay, control, curly brace, curly brace. Oh, student has a name, string name. I can describe student with set of variables. And what can student do? Set of methods. You understand me? You described. Very good. You know what a student means. But did you see a student? No. Okay. Oh, John. This is John. So John has all the things that belong to a student here. Oh, he has a name, he has a student ID, he has everything is given to him. Now John is an object of class student. John is an object of class student. So how do you create an object, sir? Student. John is J equal to new student. And in this is a constructor method. I can write down John is the first name. All the variable values, I can put it in the parameters here. This is how I created an instance of class student. You understand me? Instance of class student. This is real. That means memory is allocated for him. But class, memory is not allocated. It's only a description. Memory is not allocated. No consequence. When you declare class student, unless you create objects out of it, there's no consequence. So that's, I hope you understand part of the, this knowledge, right? This is very useful knowledge for your PC2 course and PC1 too. It will take some time for you to understand, but once you understand, that's it. It's like learning. Okay, a little baby comes in and asks you questions. At the beginning, baby mind is blank slate, doesn't have anything. So that's why, a child can speak Spanish, English, okay, or, any complicated Indian language, Sanskrit, Greek. You teach, the child will be able to do whatever you teach. Do you agree with me? So likewise, when we are giving knowledge to you, you will understand that for sure. One day you will understand. Okay, this is a class. This is another class. Do you agree with me? Okay, you agree? Yes or no?
Yes.
And there is another class here. So when you have multiple, what is a program? Set of classes. You understand me? What is a program? Set of classes. What is the name of the program? Name of the program is the name of the file that has, main function in that file or in that function, in that class. Okay, program is set of classes. If I say this is a program, so this program has how many classes?
3.
3 classes.
3.
And one of them has a method called main. Which one?
Driver.
Yeah. So name of the program, you can say the driver. Or you put another name, whatever you want. Normally people say client or a driver. Okay, people say driver. Driver is a very common word people use. Oh, see what I mean? One student will behave one way, another student will behave another way. Do you agree with me? 2 students need not be doing the same thing. One class is going to be like one story is going to be one way, another story is going to be another way. One forest is one way, another forest is another way. One river is going to be flowing like one way, another river is going to flow another way. So all are different. So that means objects are behaving. Do you agree with me? So this is a class. Okay, you can create objects out of it. This is a class. You can create objects out of it. But those objects don't need to do exactly the same. They can be different. So the action that takes place. That means objects are created and used in the driver class. So that means objects of this one must be created and should be used in the driver class. You understand me so far? And making sense out of it? No. At least the understanding part, I know that the detail of this line, it will be like a difficult thing for you to follow through, but conceptually try to take the big picture. The big picture is a program is set of classes, and there will be one class that has a main method. That is the name of the entire program. And this main method is going to use other classes. You see what I mean? Other classes to create objects and make them work. In this world, the world, right? The entire world. The world is made of countries, and we are in Canada. We are, objects are person, people, citizen of Canada. So set of citizens is a country. So set of objects. So, and how those objects are supposed to work or something is written in the main method. So let's read it. So whenever you want to read anything, right? Read the method that has, okay, you can read it here. If you want to read, you read this sum, but you get less, nothing much. What, sir? Set of variables. Can you tell me how many variables you have in this?
Just one.
Sum, just one. So that is private. What is the meaning of private? That means outsider will not be able to,
Oh, not be able to be seen.
will not be able to see. But insiders will be able to see. Insiders who, sir, get sum is a method and set sum is a method. All methods, okay, will be able to see this private variable inside the class. All methods inside the class will be able to access the private variable defined inside the class. So a variable can be seen by outsider. Who is an outsider, sir? Another class is an outsider. So another class will be able to access the sum if it is public. You understand me? If it is private, no, you cannot see. The other class cannot see, but I can see inside the class. Usually, it is a good practice to put all variables as private. You understand me? Instance variables. Private. And it is a practice that, so those variables can be set through a public methods. Can be manipulated through a public method. 1 second, I'll be back. Okay, all right. So you know what? I want you to see one thing. One thing. What is it? This class, right? This class. Which class, sir? Summation class. There is a keyword here, implements. Whenever you use a keyword called implements, it is an interface. What is it?
Interface.
Interface.
Whenever you see the keyword is extends, it is inheritance. So that means whatever you write down here is a class. That's a parent class. So whatever you write here is the name of an interface. Okay. So the interface is runnable. You don't need to write. It's already available in the library. So runnable. You just write down runnable. That means, okay. So, and the runnable is associated with a thread. Like I told you earlier. So that means you will be able to use thread through summation. So now what you have here, let's look at here. So can you tell me what is the name of the class this here? What is the name of this class?
Summation.
Summation. What is the name of this method here?
Summation.
Summation. How many variables this summation has? Instance variables. Two. This one and that one. This is not a variable. This is not an instance variable. What is it? Local variable. Local variable is a variable which is defined inside a method.
Inside the, yeah.
Inside a method. And inside a class, the variables which are defined inside a class are called instance variables. These are instance variables. So the memory is allocated for these instance variables only when you create an object of this. I know it may be overwhelming at this point of time because it requires PC1 knowledge as well as PC2 knowledge. But don't worry, you are all very good students. Believe in yourself. You will understand perfectly fine. So let me go here. Even if you get a vague idea is good. So this is the class. And I was asking, a class is nothing but set of variables and set of methods. How many methods you have in this? 2 methods you have. So this method, the name of the method is the same as the name of the class. Do you agree with me?
Yes.
So such a method is called what?
Constructor.
Constructor. Constructor is the only method which doesn't have a return type. What? Return type. I don't think methods are completed yet for you, right? Isn't it?
No.
Yeah, that's why. So you look at that. The name of the method is run here. This is a void. Void means bring nothing. Do you go to shopping and buy nothing? Yeah.
Sometimes.
Do you do? But did you do something? Yeah. What did you do, sir? I looked at the prices and I came back. That's it. I made a decision not to buy. I bring nothing. You can do. It happens quite often. And sometimes you buy and you bring a bag. What are you bringing? A bag. A bag may have many things in there, but it is a bag. Is a bag. But you are only allowed to bring only one thing. If somebody tells you that you can only take back only one thing, what will you do? So, for example, an airline is taking you and tells you that, okay, you can carry only one thing, one suitcase. What will you do? You buy a monster suitcase and you put all suitcases in that one suitcase. And then carry that one suitcase. You see what I mean? So you can only carry one thing in programming here is that return value, return type. So here, look at here. This is the main method, right? Isn't it? So main method is starting here. Main method is ending here. Do you understand me? Ending there? Yeah, it is ending there. Okay.
What does static mean?
Static means static variable. Where is it written? Written here?
No, on your last slide at the top near public static void.
Oh,
main.
I see. That's static. You have to tell me which static, because you have static methods, static variables. Okay. Static
Isn't
means
it about like because it's an object and because we are working with objects.
yeah, but you know what? Let me tell you a new concept to you. Concept is like, in Java, there is no global variables, right? Isn't it? There's no global variables in Java. There is no global methods in Java. So, in Java, anything that you want to do, you need an object. You understand me?
Mhm.
Without an object, you cannot run anything. Okay. So the workaround for that, why you have to work around, sir? If I tell you one thing, what did I tell you a few minutes ago? You cannot do anything without an object, right?
Mhm.
So then the main is a method, right? Is it not?
Yeah.
If you want to execute this main method, Any method you want to execute. What is a method? Method is action. Do you agree with me?
Yeah.
Action means what? Walking, talking, doing things, answering question, shouting, dancing, any action you want to do. These are not variables. These are actions. Actions are done by executing certain, steps, instructions. In executing set of instructions is action. Do you agree with me? And
Yeah.
you basically a method. Method will do. What is a method? Set of instruction. So who can do the instruction? Objects can do the instruction. Who can talk? A student can talk. A person can talk. A bird can talk. But can there is something Akashwani. Okay, so can you get some sound without an object?
No.
So can you have some talking without an object? No. You understand me? That means that any method that you want to execute, you need to create an object to execute. You understand me?
Okay.
But in Java now, operating system has to execute your program. Do you agree with me? All right.
Yeah. Mhm.
So that means he has to create an object of your program. You understand me? And execute that main in there. So that means if I have to remove the static here, the operating system has to create an object of your class and then run. But to be backward compatible, operating system is already written down to execute a main. So operating system will execute what? Whenever you execute a program, where does he go and start executing? He will go to the main method. You understand me? He
Yeah.
knows that he has to run the main method. So he cannot run the main method unless it is available to him. You understand me? So to be able to available, that means he has to create an object of your class and then execute this method main. So workaround is not to create an object and execute. So there is a keyword called static that makes it method to be locally global. Locally global, sir. Locally global means within the perimeter of my program is available. So and it is available to operating system also. So and because it is global, so he can run without creating an object. So whenever you keep a keyword static, you can execute that method, okay,
Okay.
without creating an object.
I see.
You can execute.
So it
If
replaces.
it is not static, you cannot do it. You want me to give an example? Let's do that.
So in a way, static replaces an object?
No,
No?
it doesn't replace. It's a feature.
It's a feature. Okay.
Yeah. So let me show you here. Okay. So you put a static main is the one which is for the operating system, not me. I won't be running main. But look at here. So let me take a small program so that you will see it. Okay, sir. Hello, new. Demo. Okay, let me take Apple. Apple is a class. Okay. All right. I don't know, maybe it will be too much for you because this is the try catch is exception handling. Okay, let me take a new workspace. Switch to the workspace PC1. Interesting question. But I normally teach that in the first lecture class itself now.
I have a question.
Go ahead, Ali.
Is there any relation between this subject with the subroutines and functions?
Pardon, I didn't understand because first I'm cutting off the thing.
I mean, it's method.
I don't know. Are you able to hear the voice of Ali? Okay, is there any relation
between the subject, I mean multi-thread, and subroutine and function.
Oh, but subroutine is nothing but a function. Method is nothing but the thing. But the thing is multi-threading.
Yes, I know.
But the threading,
I know,
multi-threading is. Let me
Yeah,
tell you
yeah.
one thing. I know what you're
Yeah.
asking. So basically, if you want to create a thread, right, that should be a method. Okay, this method here. Okay, can you see the
Yeah.
method here called run? Is a run here? Yeah.
Yes.
I'm circling here. So that's a method which is going to be executed here through the thread. So I'm creating a
Yes.
sum object. See, look at that. Sum object I created. And I'm creating a thread here with a sum object. That sum object must have a run function. And that is going to be executed when you run the thread. That's the relation.
Okay.
He won't really teach you like, I understand, when you come here, I expect that you already know methods and so on. I don't need to teach the methods. But unfortunately, that's not the case, right? Yeah. So teaching you
Yes.
only threads without teaching you what method means and what is the static means, what is all the fundamental questions you're asking me, if I don't teach them. So it is good, at least you will know what is missing in the other course, right? Let's go back here. Okay. So I have here public static. Okay. So void XX sysout control space hello Tala. Okay. So I want to execute that method. Okay. If I execute that method, it is going to tell me
Hello, Tala.
hello Tala. So to execute, this method is inside here. Do you agree with me? Inside the same class. Do you agree with me? How many classes you have? How many methods you have in this class? Two. One is main, another is XX. So you can directly execute it. XX. Just like that. You understand me? I'm calling XX here and executing. So main is executed, right? Main is executed, program is completed, executed. You see what I mean? So because you wrote down XX on top, it's not going to be executed by the operating system. Which method is going to be executed by the operating system?
Main.
Main. So main is completed, your program execution is completed. Is it clear? So if I don't put anything here, for example, it does nothing. It executes nothing, but it will not execute that XX because it is written down on the top. So it will be nothing here. So, but if take out this one, it's going to say hello Tala. Do you agree with me? Okay. So that means this XX can be executed without an object. You understand me?
Yeah.
So, but if you take out the static thing there, you need an object.
Object. Okay.
So right now, right away, you got a syntax error here. Look at that. So now to be able to create an object. So what is the name of the class that you're creating an object of? What is the name of the class?
New.
Yeah, new n equal to new. You understand me? Now n dot x. Perfectly fine. Now I will be able to execute. Hello Tala. It will print hello Tala. You understand me now? So static is a keyword that makes it a method to be global.
Okay.
Globally available to you within the class. You understand me?
Yeah.
So to be able to go outside and to be available, that is public. Okay. So you can do inside the class, outside the, so static. So use it sparingly. So whenever you want to do the work inside your home, you don't need, certain things to be able to do. So otherwise you will be able, you understood now, right? Is it?
Yeah, thank you.
Good. With an example always makes it better. So now what we do here is, I will explain this program and run this program. That is for today, right? So this one is supposed to receive some arguments. You don't need all this, I'm going to give the all. So parse int argument 0. Okay, whatever value is given to you must be greater than 0. Okay, and if I give you so some arguments are given to you, and what are the arguments, sir? The arguments is so look at that here, arg0 parse int. So there is an integer value called upper. That's what I'm receiving through arguments. It doesn't matter. I did show you how to get an argument through. Did I show you? Yes or no?
Yeah, you already gave.
Passing a parameter, I post, not passing providing an argument. So I simplified the same version. Take off all this. I don't need all this. I just put directly some value here. If I put a 10 here, why not? It will be 10. So okay, upper value 10. So summation. So you creating. Can you tell me what this means? Creating an object. Object of what? A class called summation. So that means constructor method is called. So I created an object. So when you create an object, what will it get you? Object reference. When you write down scanner, yes equal to new scanner. So what is yes? Object reference. Where are you getting from? From the statement on the right hand side. So object reference is given to you here, and that is given to you again to thread. What is a thread? I'm creating a thread object. Why? How do you know I'm creating an object? New. What is the name of the constructor? Thread. So what does it require? Whichever program you want to run, like a thread, give me that class. Why, sir? I will look for the run function in that and execute that. You understand me? Summation is this here. There's a run function that will be executed. You understand me? Okay. And because you're creating the object, upper is already set up. So upper is available to your run. And some value is, look at sum. The sum is a type of this one, right? Isn't it the class sum? And what is the object reference? Some value. So I'm creating an object of this one and then giving it to him and then giving an upper value and running this. So, and I am actually running. Okay. So the upper here, so this is the method that I'm actually running. Okay. Some value set sum. So I'm going to put the value into here. It made life complicated. You don't need to make this much complicated. But he's demonstrating something here. He created that and kept it here. Okay. And then you start the thread. So that means it's going to go and start running. And you're waiting. Join. Join means until he comes back and he'll join. I send my son to shopping and he'll come back and joins me back. So at that point of time, I have the results. I can print that. Get the sum. So it's going to execute. That's it. Try catch block is exception handling. I think probably removed it. So let me show you. Maybe I have this program here. You can ask questions, right? Don't worry about whether it is a PC1 or PC2 course, because it's prerequisite. Those are prerequisites for operating systems course, right? A little bit advanced. It will be teaching only just those, you know, what is the demos, right? It was exceptionally good, you know, but those are the demos which are written in a, you know, in your installation, preparing a PC, and those are the things which are in your course outline also. So that's the reason why I'm teaching those ones. Is in the course outline, some people were asking me. So in the past, you know, so if I go to the course outline here, right? Let me go here. Installation, preparing a PC, preparing a driver, you know, like those ones, right? So preparing a PC, accurate representation of preparing a computer. Look at that. Installing an operating system like Ubuntu, preparing a computer. These are the things also, you know, install application, perform operating system task, you know, start scheduling a task, scheduling this one, disk management. So, you know, disk failure recognition, correct writing of. Those are the things, you know, that's the reason why I'm teaching those ones, okay? Scheduling a task. And so, but the real thing is that, so the real knowledge is, you know, these PowerPoint slides are the real knowledge. Okay, those are the other ones you will do it. Anybody will do it without even taking an operating system course, right? Okay, coming back here. So the thread programming, let me see the thread here, right? Yeah, I think thread is TD. Thread example. Oh, yes. Okay, let me this one maybe. Yeah, look at that here. Okay. You understand me? Hello, anyone sees it here? I'm circling it here.
Yeah.
So what did you do? I created a project and right click on here and created a class called create class, right? You know how to do it, no? Multiple classes inside a project. A class, I create a class, I create a class and create a class. So multiple classes can be kept in one project, right? So the driver is here. Okay. So I made my life very simple. I didn't really do the way he did it in the PowerPoint slide because this is not important. He's receiving, you know, input argument and validating it. Is it greater than a, no, come on, I define it just directly. Okay. So how do you define directly, sir? Upper equal to 8. Okay. I put it directly. I didn't receive it through, you know, what is it, through an argument, and I put that value into the upper. Okay. Parse it and then do it. I didn't do that. I created, okay, some object here, just in the driver itself. Okay. So some object is a reference of sum. And another object I created is summation. Summation requires the sum object. Okay. So now I'm actually running the thread through runnable interface. Okay. You understand me? I revised it actually. I revised this to make it simple. I revised this whole thing to make it simple. Is it clear?
Yeah, yours is much clearer. Yeah.
Yeah, it's simpler. I just removed all unnecessary code. And now I start to put the start. You understand me? So that means the thread is started. Which thread is started? TH. You can have multiple threads. You can start whichever. You know, if I have 2 sons, for example, I have 2 sons for sure. So I send one guy to go to Costco, another guy go to, you know, Renault Depot, you know, and then buy things. So now he start. And then you are waiting for the join here. Look at that. Because it can throw an exception, join throw an exception. You should put that in a try block. And then there is a catch. Exception. So if I get the answer well, no problem, then I got the answer. Okay. So which object, sir, is sum object that gets sum. So it'll get me I have the sum object. So he has done the work for me and he has actually sum of what, sir? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. he'll be kept in there. You understand me? If you want me to explain more, I will explain precisely how it works. But if you know PC1, PC2, you also know precisely. So this is the one. You understand me? This is the code. All right. No? Yes, no? Is he here? Yeah. Go ahead. Somebody say, yeah. What
No,
is
I
the
was saying,
question?
I was just looking at your code.
Yeah, good. Look at it. It's very simple. Okay. This is some class. This is I'll remove this sum, take out this one, take out this inventory server. I simplified it, not really did anything different, but it is simplified. So I'm going to show you another example too in the thread programming, right? So, but I won't ask you these programs in your exams, okay? This is only learning. Your exam is going to be much simpler. So summation is implementing runnable interface, and the same thing. This is the constructor. This is the method which is going to be executing. So this method requires for sure, the sum object, right? Okay, sum object. So some value is the reference to this sum object. This is the reference here. Look at that. Can you tell me the name of the variable which I highlighted?
Sum value.
Yeah. What is the type of the sum value?
Object.
What is the name of the object? Name of the class.
Yes.
Some value is the object reference. Okay, variable is the reference. The first thing I told you last class. Okay, if I write down integer x, right? What is the name of the variable?
X.
What is the type of the variable?
Integer.
Integer. So dog D. What is the name of the variable?
D.
What is the type of the variable?
Dog.
Yeah, but one thing I can tell you now, the dog is not a primitive. Not that you know already. What you know already is integer, long, character, double. You see what I mean? Those are the ones, short, byte. Those are the types which are defined by the system. These are called primitive data types. What are they called?
Primitive data types.
Yeah, primitive data types. But anything other than primitive is class type. What can you tell me? Repeat, please.
Class type.
Yeah, anything other than primitive data types. Okay, either it's primitive data type or class data type. We cannot have anything else. You understand me? So whenever you have a class type, the variable is always a reference variable. Can someone repeat, please?
Could reference variable?
Yeah, this is a real variable, but this is not real variable. This is a reference variable. You understand me? What is the difference between reference variable and a regular variable? In the regular variable, and for a variable, you need to allocate memory, right? Isn't it? Can you tell me how much memory is allocated for int?
8 bytes? Like 4
Come
bytes?
on, int.
4 bytes.
4 bytes, yeah, 4 bytes. In that 4 bytes, if you say x equal to 55, I can write 55 here. You understand me? So you can directly use that memory for writing the value. But if it is a reference variable, memory, how much memory is allocated for the reference variable? Dog is a class. Okay, class dog, somewhere it is written, curly brace, maybe 100 bytes here, instance variables, 100 bytes instance variable, and some methods here.
Just for a quick question, scanner would be a class type?
Yes.
Yeah, okay, perfect.
Even string is a class type.
Okay.
Okay. So now you tell me all reference variables, the size of the reference variable, irrespective of whether it's a dog or a scanner or a string or whatever. Reference variable is an address. So address variable in operating systems is 64-bit operating system is 64 bits. 32-bit operating system, the address variable is 32 bits. You understand me? 64-bit operating system, 32-bit operating system. Can you tell me what is the difference between 64-bit operating system and 32-bit operating system? I already just told you. The address variable is 32-bit. And that means the register that the operating system is using is 64-bit register. Register is what? A piece of memory, right? Okay. Register is a piece of memory, hardware protected hardware. So there are, set of registers are given to the operating system, and operating system is programming those. Stack pointer is a register, PC is a register. Okay, all those registers are special registers. And the programmer also is given set of registers, 32-bit register, 64-bit register, depending on, if you look at the operating system programming manual, so you'll give you all the register sizes, and then you can, which one can be, sometimes, right, you can take two 32-bit operating, two 32-bit registers can be read like a 64-bit. So, and registers can be directly 64-bit. So now, so based on that, so all references is only 64-bit. What you can put in a reference is only reference. You understand me? So that means what? The size of the reference variable, irrespective of the dog or a cat or a string or scanner or whatever, is this reference variable size is 64-bit, which is 8 bytes, right? Isn't it? Can you repeat, please?
8 bytes, 64.
Yeah, 64 bits. So that means you can put only reference in there. You cannot put anything. Okay. So what is a reference? An address. What does that mean? So dog D equal to new dog. So that means when you write like that, right? So D is allocated, 8 bytes are allocated for D. D is 8 bytes. Okay. On the right hand side, what you have is creating an object. And how much is the object size? Can you tell me, please? How many bytes?
100.
100 bytes. 100
But it
bytes
will,
are allocated.
yeah,
Pardon?
Professor. For the object, it will be like dynamic size because it's stored.
Yeah, whatever is not dynamic. It is still it is dynamic. Memory is dynamic. Yeah, memory is dynamic. Not only dynamic, but also inside the dog, how many variables you have? Those many instance variables are allocated memory for it. You understand me? Bilal, you're
Yeah.
right.
So the reference, it will be fixed. It's based on the operating system.
Wherever is the memory, this can be allocated in the heap. It could be like address 5000, address 7000. It could be anywhere. And that reference is written down here. You understand me?
Yeah.
So the data structure which is going to be created is two parts. One is D, another is the object itself. You understand me? Okay. So for example, integer age. If I write down integer age inside the dog. So age is a variable somewhere here. That is 4 bytes. So if you want to get that value, d.age. You see what I mean? If you want to get the value, that is a d.age. D.age is going to get you the age of the dog. This is dog D1. You can create. Can you create another dog? Yeah, because the age of one dog is not the same as age of other dog. So D1 is one dog, D2 can be another dog. So that means you want to create another dog. Dog D2 equal to new dog. This dog is not the same as other dog. So objects are created and then they have values. You know, they can, one dog, D1 is barking and D2 is not talking, you know. So action takes place when you create objects. I'm sorry, I'm deviating too much, I think. But you understand, yes or no?
Yeah. It's a little bit clearer, yeah.
Yeah. So now, because this whole thing is going on like that, so if you run this now, let's run this program here. Run this. So it'll get what? Is printing. So I'm run method, sum equal to 36. Okay, inside the run method, so I'm run method. You know, why did I do that? Because I wanted to show that this is actually executing. Because you may be skeptic. How do I know, sir, is run is executing? I have to believe you? No, you don't believe me. So I just printed it. I'm the run method. The sum is 36. And then when you come back to the join, right? Join where, sir? In the driver. And then the sum is available to you. I'm the driver method. The sum equal to 36. You understand me? Why 36? I think I gave you 8, is it not? The upper is 8. So 1 plus 2 plus 3 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. This is 9, right? Do you agree with me? That is 9, right? Do you agree with me? This is 9, right? Do you agree with me? This is 9. How many 9s you have?
4.
4 9s is how much?
36.
Yeah. Okay. Okay. R, the arithmetic series, what is the sum of arithmetic series? N multiplied by n plus 1 divided by 2, right? Isn't it? N is 8. N plus 1 is 9. Divided by 2 is
72 divided by 32.
no. Why don't you cancel 8 and 2? 4 9s is
36.
okay. So you understand, right?
Yeah.
Is it okay? Clearly understood or no? So let me repeat again, recap, and I'm going to show you another example to you about the thread programming. Okay, which is going to be like a concurrently running, you know, and then do like multiple threads running at the same time. I'll show it to you. Multiple thread. It's only just showing you one thread here. So concurrency, you didn't see it. But you have seen thread is being executed. So I'll show you multiple threads and the issues that come with the thread and other things I'll show you in the next class. But you know, let me show you again. So this is the main method. So main method is creating an object of a class. You look at some object. And even I can simplify this. You know, you don't need all this. You know, some object is created and all that, right? You don't need it. Only you need is summation. You know, because it created more jargon. There's no need for the jargon. I didn't remove everything from the one which I have. Okay, so I have it here. So how many slides we have completed so far? Let me see it here, maybe 30 slides. 27. Yeah, I think 27 slides. Not bad. So one more class, I think I'll be able to finish it. Forking and so yeah. Okay. All right. So good. Any questions about this whole story that we did so far? Any questions you have? I know you are not aware of this, some of these, but you are very good students. All of you are very good students. You're following. Some bright students are in the class. Other students are also happy with the other people, you know, because they don't ask questions, but you know you'll get answers for those questions. And then if you follow through the people, you learn, you know, the lot of knowledge through discussions and you know speaking to each other. Okay, and you know objectively means, you know, a friendly way. Okay. During my college time, I fortunately have good friends who every time we used to learn ourselves. Okay. Any questions you have here? Anything that you want to learn about this program? Other than that, I think I'll start. Oh, we want to do some more algorithms, or what do you want to do tomorrow? If I've opened the algorithms, I think it'll take till go to 12:30, right? Maybe one example I can finish and go. You are a very nice people. You're all nice. Class. Okay, I think we did longest round robin, non-preemptive priority. We didn't do it, right? Did we do? Did we do priority? I don't think we did the priority.
No.
So we can do one priority algorithm. So lowest value is highest priority. Okay. Lowest value is highest priority. So non-preemptive algorithm. Priority is allocated, that's it. So once you allocate it, that's it. So let's look at here. So priority number is given to you, right? Isn't it? Okay. So which one arrival time is what? 0, 1, 2, 3, 4, 5, like that. So at time 0, which one came in?
12.
12. No, the priority is 12, but which process came in?
The first.
The first one. At that point of time, priority doesn't matter. If there's only one guy there and there is a whatever priority, you will take him. Do you agree with me?
Yeah.
So you take him. P1 is taken. Do you agree? And until he completes, he will not, because non-preemptive algorithm, priority based algorithm is non-preemptive algorithm. So that means I finish at 8. Do you agree with me? I finished at 8. In 8, all processes came in. Do you agree with me?
Yeah.
Yes.
Yes.
So now you look at the priority, the lowest one first. Which one is the lowest value?
P4.
3.
3 is
So 3 is taken and finish it. 3
That's
is
4.
how much time it requires? 3?
no.
3
2
requires 4. So 8 plus 4 is 12, right? Okay, I'll write down here on the side. It will be easier for you. So P1 came in, so started at 0 and then finished at 8. And P3 came. P3 is the next priority one, finishes at 12. Do you agree?
Yeah.
And then the next
P4.
priority one,
P4.
P4 or P6?
P6.
P6. So P6. P6, how much time requires?
3 seconds.
3. It's going to be 15.
3.
Okay. So the next one is
P4.
P4. P4. P4 priority is 9. So how much time it requires? 2. That's 17, right? Isn't it?
Yeah.
Yeah.
And the remaining one?
P5.
P5. Okay. P5 finishes at what time? 10 more, right? 27.
I have a question.
Go ahead.
Why like 12 seconds? Why don't go to P4 for so instead go to P6? Because
Because
P4
the
2 seconds.
priority is 9 for 4 and 8 for 6. So since it's the lowest, it goes to 6.
P4 is 9, right? P6 is 8, right? Isn't it?
Okay, priority is first come, first serve.
No.
Oh, it's priority.
Priority. Lowest value, highest priority. Maybe you're confusing the number, right? No, highest number is not the lowest number is highest priority. Okay. So now you go to the P2, the last one, and the finishes in 33. Do you agree? Yes or no? 27 plus 8 is 33. So now you can actually finish out this CT. Yes or no? Completion times and TAT minus CT minus AT. WT means TAT minus BT. And response time. P1 response time is 0. P2 response time is when did he come at 1 and when did he take 27? That means 26, right? Yes or no?
Yeah, it will be the same like the waiting time because it's
No, it's not. Oh, yeah, you are right. Absolutely. Because non-preemptive algorithm is absolutely right, Bilal.
Yeah.
You know. Yeah, you can even blindly write this. Okay. So preemptive version of the same. Whenever you have a preemptive version, okay, or the priority algorithm. So that means if someone comes, you have to give him the way through, right? That's preemptive. Preemptive. Non-preemptive version, preemptive version. Priority-based algorithm has two versions. Priority. So let's look at now. Okay. So I'm going to write again the same story. All right. You start at time 0. Is anyone came at time 0?
One.
P1 came in time 0, right? Right?
Yeah.
So in in 1 unit of time, P2 came in, right? Isn't it? And he has higher priority. Do you agree?
Yes.
So I have to go outside and I have to let him in. You understand me? So the remaining time to finish is 7. Okay. So now I will get him on board P2. And a P3 came in at time 2. Do you agree with me? So he has to go out also. Do you agree? And give him P3. P3 is a higher priority. Okay. P4 came in, but not higher priority. P5, so highest priority is P3. You agree with me?
Yeah.
So, and he is going to finish for sure. So P3 is going to finish for sure. Do you agree? So 4 units of time is going to finish at 6. So P3 is actually finished as work. Do you agree? Yes or no?
Yeah.
So in 6, all of them came. Do you agree? So which one is the highest priority? Now look at the priority, the lowest value, highest priority. So
Six.
take out this one. So P6, P6, no, not P2, P6. P2 is 11, P6 is 8. So P6 is 8. So 3, and it remains to be the same one, which is going to be 9, is going to be finishing at 9, right? Isn't it? Do you agree with me? So he finished. So the next one is
4.
P4. P4 is going to be finishing. How much time you need? 11,
Two.
right?
Yeah.
2 units. So it's finished. 0. Do you agree? Yes or no?
Yeah.
So now remaining ones is P1, P2, and
P5.
Five.
P5. P5 is the lowest. 10, 11, 12, right? P5. So that is going to be finishing what? You need 10 units of time. It's going to be finishing at 21. And then P2 is 11. And the remaining time, just add that 26. And P1, remaining time, add that 7 is 33. You agree with me?
Yes.
So now you can actually work out the CT. Do you agree? So CT is 33 for the first one, 26 for the second one, 6 for the third one, and 11 for fourth one, the 21 for fifth one, 9 for the sixth one. So you got that. So TAT is CT minus AT. You can work out that. So WT is TAT minus BT. You can work out that. And then response time is 0, you got here and got here. Response time is 0, you got right away. And response time is 0, you got right away. Response time is this one is 6, right? So how do you 6, sir? So P4 came in, I taken at 9, P4 came in at 3. So 9 minus 3 is 6. And P5 came in at 4, but it taken at 11. So, okay, 11 minus 4 is 7. So this is 0, like 6 and 6. Okay, so you know response time also. You agree? Yes or no?
Yes.
Yep.
Very good. So shortest remaining time first. Shortest remaining time with, with requiring IO now, right? Isn't it? IO means you require some IO time. IO time means go out and then come back again. So the total burst time is given to you. Okay, it's a preemptive algorithm. Every time you need an IO, so that means you have to preempt him. Okay, so IO time is here. Burst time and IO execute some time, and then you need to do IO, and then again take a burst here. So that means 2 burst times you given to you here. So it can be multiple times you want here, right? So at the beginning, pay attention. This is a little bit a tricky one. So at the beginning, okay, which process came in?
Both 1 and 2.
Yeah, 1 and 2. Which one has a higher priority? Is there any priority number?
No.
Shortest remaining time, right? I'm sorry, it's not a priority. Shortest remaining time. So shortest time is which one?
Process 2.
2.
Process 2. Okay. Process 2 is the shortest time. So you take him 0, you finish at 2, right? You agree with me? The burst time is finished here. Okay. So 2 at 2, who came?
Process 3.
3.
Process 3. If he comes before, for example, you have to preempt him. Okay. Because it's the shortest time for him, burst time. So now P3 is taken, right? Do you agree with me? P3 is taken?
Yes.
Okay. When P3 is taken, P2 should be kept in the queue. Do you agree with me?
Yeah.
Yeah.
So you kept in the queue. Okay. So it is waiting for IO. Do you agree with me?
Yes.
Is it waiting for IO? Yeah, it is waiting for IO, right? Is it not? Hello?
Yeah.
So IO time is how much?
4.
So he's going to come into the back again to the queue at where? So 2 plus 4 is how much?
6 seconds.
So he will come back at 6. See that here? He come back at 6. End of 6. Yes or no? Maybe I should do it one by one, right? Otherwise, it will be confusing to you because you want to maintain the queue. So, okay, all right. So, and is it clear that I can take P1 back again here? Not P1 back, sir. P1 is the first time here.
P3
Because
has
P3 is finished, no? P3 is
is already finished.
P3 is only 1 unit of time and then goes to IO. So that means he will come back again at 6, right? He come back at 6 and he also comes back at 6. But the sequence is going to be P2 and P3, no?
Sir, could you just
Yeah.
draw it one by one? It's
Yeah.
going to be more clearly.
Yeah, it'll be 1 by 1. So let's do 1 by 1 again. Okay. All right.
Yes.
Okay. So let me do it again, right? Here, look at that. So first one, it comes to you is what? P2, no? Why P2? Because 2 processes came at the same time and the lowest burst time is
First.
this P2, no?
Mm.
P2, lowest burst time. Okay. The remaining time is total burst time. Total burst time first. Total burst time is how much? Can you tell me? 5. And the total burst time is
3.
3. And then which one is smaller?
P2.
P2. So, and it's preemptive algorithm. So this starts at 0. And if you go to 1 and no one there, 2, at the time of 2, P3 came in. Do you agree with me? Okay. Hello.
Yes.
So now the burst time is finished here is 2 is finished. So 3. Do you agree?
P1 is
That's
5.
one.
Sorry. I think it's control Z. I don't think control Z works. I'll take out this. This one is 0, no? 2, 1, right? Sorry. I'm just making. So 1 here, right? Is it not 1?
Yeah.
So 1. And then it goes to IO, right? Is it not? It goes to IO, right? Is it not?
Yes.
So when is it going to come back to you? At 6.
6.
Okay. So that means P2 will come back at 6. Okay. Do you agree? Yes or no? So now after P2, so which one will you take? In 2, so the another process came in. Do you agree with me? P3 came in and his burst time is. So
3.
this is the 5, that is 3. Which one is smaller?
P3.
P3.
P3. So P3 you take. So P2 is going to be coming back again. Do you agree with me? So now P3 is 1. That means how much is the burst time you require for the P3? Burst 1.
1. Yeah, 1.
Is only 1. So it's going to be finishing at 3, no? It's finishing at 3. And it goes
Yes.
back to Q again. How much is the IO time?
3.
So it's going to come back at 6.
6.
Exactly 6. Exactly 6. Do you agree with me?
Yes.
So exactly at 6 is comes back. So now which one will you take? So at 3, anyone came in? No, 80 is P4, 80 is 5. So he didn't come. So now you compare all 3 of them, and which one is the one you want to take? There's only one left, right? Is it not?
Yeah, because P2 and P3 waiting for the input
Yeah,
output.
exactly. They're already scheduled to come back at 6. So they can't really be taken. So P1 is taken. P1 is taken until what? So how much time?
And
So
2.
yeah, remaining. So when you come to 4, when you come to 4 and 5, so when you come to 4, it's going to be 4. Remaining time is going to be 4. And when you come to 5, remaining time is going to be 3. You agree with me?
Yeah.
And when you come to 6, remaining time is 2, right? Is it not? So that means P1 finished 3 units of time. Do you agree with me? And it goes for IO now. How much time it will come back again?
2 units.
At 12, right? Is it not? 6 plus 2, 8, is it not?
Yeah, just 2 units.
8. It has to come back at 8. So 6 is here. So now I will put that back again in the queue of P4 here. P4 comes back, is it not? P4 is already in the system, and it is only 3. Okay. Do you agree with me? Yes, no? Hello?
Yes. Yeah.
So and P6, P4 will go here. So now at 6, these are the people waiting. So which one will you take?
P2.
P2. P2 will finish the second burst, isn't it? So only how much is left out of the second burst? Only 1 unit, right? Isn't it? So P2 will finish at 7, no? Okay. So P2 is finished. P3 is taken now, isn't it?
Yeah.
And P3 is taken. And how much time does it require? P3 is also doing the second burst, isn't it?
Yeah.
No, P3 is doing the second burst. Second burst is 2 units. It's going to be 9, right?
Yeah.
9. So P3 finished, no? Yes or no?
Yes.
Yeah.
So P4 is left out. P4 is taken now.
I think we should take P1 because it
Oh,
back
yeah, you're
from,
right.
from the
Yeah, P1 is back again, right? At what time P1 was coming back actually?
I think at 8.
At 8, right? At 8. So P1 comes back at 8. So that means it's waiting, but still shortest is P3, right? Because it's 2. Shortest is P3, so it will go up to 9, but you will take P1 here, no?
Yeah, because
Yes or
it's
no?
because it's just 2 units, and P4 yeah, 2 units, but I think because P1 comes first, so we will take it.
Yeah. So, and now what? P4. P4 is how many units are left here? P4 is not taken. 3 units. So P1 will finish at 11, no? Is it not 11? Because 2 units are left out, right? Is it
Yeah.
not to him?
Yeah.
So you finish at 11. Okay. So P4 is the only one which is left out now, right? Is it not? So you should take the P4 and do the burst of first burst is 2 units, which is going to be 13. And then he has to wait until he has IO time completed. And then P4 is taken back again. And then first burst 2, second burst is 1. So it's going to be 15 here and 16, no? Is it clear now? Yes, no?
Yes.
So now you can actually work out the CT. Okay, completion time. P4 is 16. Go in the backward direction, right? P4 is 13. P4 is 16, and P1 is 11, and P3 is 9, and P1 is P2 is 7. Yeah. So that's correct. So TAT is CT minus AT. WT is TAT minus BT. So now the remaining time is because the shortest remaining time first. So I arrived at 0. So, but I need to wait for first time I was taken at 3. So 3. So, and the P2 is taken right away. P3, it came at 2 and taken at 2, and it is also 0. P4 came at 5, P4 came at 5, and then taken first time at 11. So 11 minus 5 is 6, right? Okay. Is it clear? Yes or no?
Yes.
Okay. I think the remaining one will do tomorrow. Okay. I'll stop here. And then 2 more slides we have to finish this. And that's it. Only 2 more slides. Okay. All right. You want more?
No, we can stop here.
Stop here. Good. You are all very good students. Thank you so much and enjoy your day. And that's it for the day.
Thank you again.
Thank you. Have a nice afternoon.
You too.
Thank
You
you.
too.
Bye.
Thank you.
Okay.
You have a nice day.
Good.